This is Miss Cucci's college now pre-calculus. This is Miss Cucci's.
So today in class, what we're going to be talking about is finding the product of matrices. Matrix multiplication is defined in such a way that it can be used in solving systems of equations and in a lot of different applications. So matrix multiplication, the definition being for when a m times n matrix A and n times n matrix B, the product of A and B is an m times n matrix. Okay. I could give you this big, long, ugly thing. I'm not going to do that. What I'm going to do is actually show you the example. I think you'll gain a lot more from that than going through that definition of it. Okay? So, in other words, the entry C sub ij in the matrix A times B is attained by multiplying the entries in row 1 of A by the corresponding entries in column J of B. Okay? And then adding the results together. So you're going to see what this looks like. It will be much easier once you see it actually happening. Okay? All right, so what we need to do is first know what our matrices are. So, whoops, hold on one second. Okay, so for my matrix here, we have matrix A, which is 3, 2, 1, 0, negative 1, 3. And we have matrix B, which is 1, 3, negative 2, 6, negative 5, 4. And we have one more matrix, which is matrix C, 4, 1, negative 6, 2. Okay, so 3 matrices, a 2 by 3, a 3 by 2, and a 2 by 2. All right, so my first example is going to ask us to find the product of matrix A and matrix B. Okay, so we're going to actually start by doing that. So, move these up here. So in order to find A times B, since A is a 2 by 3, and B is a 3 by 2, my product is actually going to be a 2 by 2. Okay, and we get that by my first and my last. Okay, that's where you're getting that from, the first and the last. So here's how this works. I'm going to write down my matrices side by side. So 3, 2, 1, 0, negative 1, 3. And then 1, 6, 3, negative 5, negative 2, 4. All right, so the way this multiplication works, again, it's going to be a 2 by 2. You've got 3 times 1. So first row, first column, first row, first column, plus 1 times 3. First row, first column, second row, first column, plus negative 1 times negative 2. And that's your first row, third column, third row, first column. That's your first one. Then the second part is 3 times 6. First row, first column, times first row, second column, plus 1 times negative 5, plus negative 1 times 4. Okay. Now for the second row, 2 times 1, plus 0 times 3, plus 3 times negative 2. And 2 times 6. So essentially you're taking this and you're going down the row. Plus 0 times 5, plus 3 times 4. Now we're going to do the math here. 3 times 1 is 3, plus 3, plus 2, which is 8. 18 plus negative 5 plus negative 4 is 9. 2 plus 0 plus negative 6 is negative 4. And then 12 plus 0 plus 12 is 24. Oops, sorry about that. 24. Okay? So that's the product of A and B. All right, so now we're going to try B times A. Okay, so B times A, I'm going to write them side by side. 1, 6, 3, negative 5, negative 2, 4, and then A, which is 3, 1, negative 1, 2, 0, 3. And since this is a 3 by 2, and this is a 2 by 3, this is going to give us a 3 by 3 matrix. Okay? So, we're going to start with the 1. 1 times 3 plus 6 times 2. Okay, 1 times 3, 6 times 2. Second column. 1 times 1 plus 6 times 0. Third column, 1 times negative 1 plus 6 times 3. Okay. Next one down, we've got 3 times 3 plus negative 5 times 2. 3 times 1 plus negative 5 times 0. 3 times negative 1 plus negative 5 times 3. And last but not least, negative 2 times 3 plus 4 times 2. Negative 2 times 1 plus 4 times 0. Negative 2 times negative 1 plus 4 times 3. Okay, we do out the math. We get 15, 1, 17, negative 1, 3, negative 18, come on, 2, negative 2, 14. All right, so once you get in the habit of doing this a few times, it's really not difficult. You just have to remember what to multiply by what, okay? Okay, so the next one is B times C. So again, we write them down side by side. B is 1, 6, 3, negative 5, negative 2, 4. And C is 4, negative 6, 1, 2. Here we have a 3 by 2. Here we have a 2 by 2. This is going to be a 3 by 2. Okay. So, let's begin. You've got your 1 times 4 plus 6 times 1. So 1, 4, 6, 1. Next one is going to be 1 times negative 6 plus 6 times 2. Next row, 3 times 4 plus negative 5 times 1. 3 times negative 6 plus negative 5 times 2. Next column, negative 2 times 4 plus 4 times 1. negative 2 times negative 6 plus 4 times 2. Do out the math, and we wind up with 10, 6, 7, negative 28, negative 4, and 20. And there we have our 3 by 2 matrix. Okay, so let's try D. So D is asking us to multiply the matrix A to the matrix C. Well, the matrix A is a 2 by 3. Okay. Matrix C is a 2 by 2. We actually can't do this. Okay, this is not defined. Hopefully you can read my cursive, because the number of columns of A, which is 3, is not equal to the number of rows of C, which is 2. Okay, the number of columns for A has to be equal to the number of rows for C. And since they're not, this can't happen. Okay? Which saves us some time. All right, so let's go ahead and look at example 7 now. Just erase this real quick. Maybe we will look at example 7. Okay, so this is talking about a bakery profit. The 2 items sold at Sweet Treats Bakery are gluten-free bagels and gluten-free donuts. The table below lists the number of dozens of each product that are sold at the bakery's 3 stores in 1 week. The bakery's profit on 1 dozen bagels is $5. Its profit on 1 dozen donuts is $6. We're going to use matrices to find the total profit on these items, T, each store for the given week. Okay, so the first thing we need to do is we actually need to come up with a sales matrix. Okay, we'll call it sales. So what are we actually selling? And just like we've done before, you're just taking that data and you're putting it into a matrix. Okay. Then what we need to do is we need to make a profit one. So what are we actually making on this? And that's going to be a little bit more simple because we just have our $5 profit and our $6 profit. Okay, so our X is our bagels and our Y is our donuts, right? Okay, and these would be our stores. The 3 would be our stores. So in order to determine this, we need to actually take our profits and our sales and multiply them by our profits. So, you know, if we sell 25 dozen, how much money is that? Well, 25 dozen times the $5 profit. Okay, so we're actually finding P times S. So you've got our profit, 5, 6, and you've got our sales, 25, 30, 20, 40, 35, 15. So we're going to go ahead and multiply those, and since this is a 1 by 2 and a 2 by 3, we're going to have a 1 by 3. So when I multiply these out, we get 5 times 25 plus 6 times 40, 5 times 30 plus 6 times 35, 5 times 20 plus 6 times 15. Okay, so what that actually equals is 365, 360, and 190. Okay, so what does that mean? Well, it means that our main store is going to have a profit of 365. Our Avon store is going to have a profit of 360. And our Dalton store is going to have a profit of 190. Okay, so that's what that means. Okay, so last but not least, we're going to talk about some properties of matrix multiplication. Okay, and these are just our properties that we talked about before, associative, so on and so forth. So with matrix multiplication, we're really only dealing with two. Okay, we are dealing with associative. So basically, if you have matrix A and B and C, this is going to be the same as if I multiply A and B together first and then multiply in C. Same thing. And we know that's associative. The other one we're going to deal with is distributive. So A times the quantity B plus C is going to be equal to AB plus AC. And likewise, B plus C times A is going to be equal to BA plus CA. And these are both distributive. Okay? All right, so let's talk about matrix equations, and then we are done. So hopefully we'll finish this before that 20-minute mark. And if we don't, I apologize, but I'm going. Okay, so matrix equations. We can write a matrix equation using equivalent systems of equations. We're going to write a matrix equation equivalent to the following system, which I'm going to give you now. Okay, so let's say I have 4x plus 2y minus z equals 3. And I have 9x plus z equals 5. And I have 4x plus 5y minus 2z equals 1. Okay. To get a matrix equation, all you do is you take your coefficients. So 4, 2, negative 1. 9, 0, since I don't have one, 1, 4, 5, negative 2, and you put them in a 3 by 3 matrix. Then you take your variables, which are x, y, and z, and you put them in a 3 by 1 matrix. And then you take your answers, your constants. Okay. So what we can say is we're going to let matrix A be our coefficient matrix. And we can let matrix X be our variables. And B be our constants. So we can write this matrix equation as AX equals B. All right, that is all she wrote today. Please come prepared with any questions that you might have, and I will see you tomorrow.